Okay, 12.4, it is مسك الختام for chapter 12 and for the whole course, inshallah. Indeed, we already distributed this section over the previous 3 sections. So, in fact, the shifted parabolas, we have studied them in 12.1, the shifted ellipses in 12.2, and the shifted hyperbolas in 12.3. What is remaining is just the general equation, and we mentioned it also in 12.2 and in 12.3. Just let me make sure that we are sharing the screen on Zoom. Yes, I think we are sharing. Good. Now we need to refresh our memory before going further. What are the conic sections? They are curves formed when a plane cuts a cone. And we have, in fact, mainly three conic sections. Let me go and remind you about this YouTube video that we have seen together. We have watched this together at the beginning of chapter 12. Let's now revise it quickly and focus on the case that may happen, which is called the degenerate section or conic sections. Okay, let me just open the sound.
Circular cone, we get two-dimensional curves of different types. These curves are called conic sections. Depending on the angle made by the plane with the vertical axis of the cone, the plane can cut the cone in 3 different ways. Ellipse. When the plane intersects the double right circular cone in such a way that the angle between the plane and the axis is greater than the vertex angle, we get a closed curve called an ellipse. When the plane is perpendicular to the axis, the ellipse becomes a circle. Thus, a circle is a special type of ellipse. Parabola. When the angle made by the plane to the vertical axis is exactly equal to the vertex angle, we get an open curve called a parabola at the intersecting surface of the cone. Hyperbola. The plane intersects only one nap of the double right circular cone as long as the angle between the plane and the vertical axis is greater than or equal to the vertex angle. However, if the plane intersects the vertical axis at an angle smaller than the vertex angle, the plane intersects both the naps of the cone to form an open curve called a hyperbola, which has 2 disjoint curves. Degenerate conics.
I want you to pay attention to the next few seconds of the video. It is about degenerate conics, what they are, from where they come. In fact, you will see this situation when you complete the square. When you complete the square, you will get a hyperbola or an ellipse or a parabola, but in some situations, you will not get any one of these 3. This is what is called the degenerate conics. Let's see geometrically how they obtain.
If the plane intersects the double right circular cone at its vertex,
so if the intersection between the section and the cone, it is at the vertex at one point only. So it will not be a parabola, it will not be an ellipse, it will not be a hyperbola, it will be just a point, a single point. And this is what he's talking about.
The ellipse becomes a point, the parabola becomes a line, and the hyperbola becomes 2 intersecting lines. The figures so obtained are called degenerate conics.
And there is, of course, a fourth case, that is when no intersection between the section and the cone are obtained. We have no graph at all in that case.
In this module, you have learned.
Let's now go back to the slides of section 12.4. So now, if we expand, you remember the standard form of the equation of the ellipse, the hyperbola, the parabola. If you expand, you will get equation like this. For example, if you have x minus 1 all squared over 2 plus y plus 2 squared over 4 equals to 1, for instance. If you expand this x squared and then multiply both sides by 4, and you will get something like this at the end. This is what is called the general equation of a shifted conic section. Conversely, also, if you started with this equation and you complete the square, you will get the standard form. And you can know, of course, which type of is this conic section. But in some situations, you will not get a hyperbola or an ellipse or a parabola. Indeed, what you will get what is called a degenerate conics. It could be a pair of lines or a line in some situations, of course, if both A and C are 0. This is not the situation here. Or you may have a single point or no graph at all, non-existent graph. Of course, if the equation is not degenerate, then we can tell whether it represents a parabola or an ellipse or a hyperbola. How to know? You can know from the equation here, from the general equation. First of all, we assume that A and C are not both 0, because if A and C are both zeros, what we have? We will have a line, and this is, of course, one of the cases. But this is not the case that we are talking about here. What we are talking about here, that if one of them, at least one of them is not 0, then this will be either, this equation will be either a conic or a degenerate conic. If it is a degenerate conic, means what? It means pair of lines, single point, or no graph at all. If it is not, if it is non-degenerate, then it could be a parabola or an ellipse or a hyperbola. It will be a parabola if A or C is 0. One of A and C are zeros. So if A is 0 or B or C is 0, we will get a parabola. If both A and C have the same sign, then it will be what? An ellipse. If both are positive or both are negative, it will be an ellipse. If they have the same sign and the same value, if A equals to C, it will be what? A circle. And finally, if they have opposite signs, if one of them is positive, one of them is negative, then we have a hyperbola, if it is not degenerate, of course. Let's take an example. What do you think? What is this? Is it going to be what? As an initial guess, it might be. If it is not degenerate, it looks like it is going to be a hyperbola. If it gets lucky, of course. We will see what we can do. What we will do, we will complete the square. This is, of course, what we usually do to have the standard form. To complete the square, you need to add, of course, complete the square in X and in Y. And here we are. You can also do one more step. You can divide both sides by 9, but it is in fact useless step. Because now, is it a hyperbola? No. Why? This is not a hyperbola. Clearly, the right-hand side is what? Is 0. If it is any other number, we can continue. Not necessarily 1, by the way. If it is 2 or 3 or -4, whatever, you can divide by that number and you can get the 1. But here 0, divide by what to get 1? By nothing. So this is not a hyperbola. Unfortunately, it got unlucky. So what? What is it if it is not a hyperbola? It is degenerate hyperbola. It is degenerate hyperbola. To know what is it exactly, what you can do, you can continue solving for what? For y. Do you remember how to find? I told you how to find the asymptotes of a hyperbola. If you have a hyperbola, to find asymptote, replace 1 by what? By 0. So it is expected here to get the asymptotes. Look, if you try to solve it for y, take the square root of both sides, you will get 2 lines. These lines, in fact, they are the asymptotes. So this is what is left after the hyperbola. The hyperbola has been degenerated, and what is remaining is the asymptotes of that hyperbola. So this case is called degenerate hyperbola. You can also get similar cases for the ellipses and parabolas. For example, take this one as an example. It looks like it is what? An ellipse. Why? The coefficients of x squared and the y squared, they have the same sign. Both are what? Are positive. Okay. So if you completed the square, you will get an equation like this. What is it? Is it an ellipse? Is it an ellipse? Yes. Who said yes? Are you sure that it is an ellipse? Is it written in the standard form? How to write it in the standard form? You have one step. By -4. So let's multiply by -4. So it will be -4 x minus 1 all squared minus y plus 1 all squared equals to 1. Is it an ellipse? It is not. It is not. So what is it, Jabal? It is degenerated ellipse. But what is it? We have 3 cases for the degenerate. It is either pair of lines, 1 point, or no graph at all. No graph at all, Shabab. Let's take the easier case. The easier case. If you have x squared plus y squared equals to -1. Similar to this. Is it possible to have x and y here? Give me any x and y that can satisfy this equation. You have something positive plus something positive. How can be negative? Impossible. This is impossible. So no x and y satisfy this. So similarly here. So in this case, we will say that this equation has no solution at all. And this graph, of course, this equation, it is not equation of any graph. So the solution set is the empty set, and there is a non-existent graph in this case. There is an interesting case also that may happen if this is 0, Shabab. If you have, for example, x squared plus y squared equals to 0, like here, if this is 0, what is the case? A single point, Abdurrahman. Excellent. Look at this easier one. What is x squared? Only 1 point, which is 0 and 0. What is the case here? If this is 0, what we will get? What is the point? 1 and what is that? The center. So the center, in fact, the ellipse or the circle in this case, they have been, of course, degenerated. What is left after them is just what? The center of them. Like the case of the hyperbola, they have been degenerated. What is left is the asymptotes. Excellent, ya Shabab. Now, I believe now you can now solve this recitation exercise. We will not solve it. I will leave it for you, by the way, because you know how to complete the square, right? What do you expect the first one will be? If it is not, of course, degenerate. It will be an ellipse because both coefficients of x squared and y squared are what? Positive. They have the same sign. Not only that, both are positive and they're equal to each other. So what? It is a circle indeed. Not only an ellipse, it is a circle. And this is the equation. If you complete the square, you will get this equation. Please try to practice. And I will upload also the full solution for you to in the Blackboard, but please try to practice by solving it completely. B, what about B? Opposite sign. So it is expected to be what? Or a degenerate hyperbola. Okay. Here it is. It is a hyperbola. The third one, they have, of course, the same sign, but not the same value. So it is an ellipse. It will not be a circle. It will be an ellipse. and it is an ellipse, of course. If it is not an ellipse, it will be either a point, a single point, or a degenerate ellipse, which will be, of course, non-existent graph or a point. Now, I have a very interesting exercise from your textbook and also similar to some old exam questions. Try to solve it, please. Determine the value of f for which this equation represents an ellipse or a single point or no graph at all. What do you think? What is the value of f that you may choose? First of all, what you should do to solve? Expand, complete the square. You are right. So start, ya shabab, expand as one of you suggested, then complete the square and decide after that. Let's do that together, please. In your notebook, try to do it, and I will do it here for you, just to save some time. So we will get 4x squared plus 4x plus y squared minus 8y equals to negative f. Then we will take 4 as a common factor, x squared plus x. What we will add here? No, fourth, be careful. Fourth, we will add fourth and subtract fourth, plus y squared minus 8y, we will add what? 16 and subtract 16 equals to negative f. So this is 4x plus a half all squared. This is minus 4 by 4, it will be minus 1 plus y minus 4 all squared minus 16 equals to negative f. This is 4x plus a half plus y minus 4 all squared equals to, this is negative 17, it will be 17 minus f. Now this is the equation that we can stop at. Now what we can do to continue, or what we can decide here. I think you can now, ya shabab, find out what is the value of f that make this an ellipse. Of course, clearly this is a plus, and here you have squared, of course, squared. So it is a hyperbola, sorry, an ellipse if this is what? If this is 1? If this is equals to 1? Do you agree with Ryan? Yes. If it is 4?
If it's greater than 0.
This is so important. Look, Ahmed, what Ahmed is saying is very important. Repeat what you said, please. Any positive number. Why 1? Why 4? Why not 3? So here, if this is positive, whatever it is, let's say, for example, it is 3. What you can do? You can divide by it, right? So all what we need to do to get this one equals to what? 17 minus f greater than 0, strictly greater than 0, which means that f is what? Less than 17. Any number less than 17 will work. But of course, 17 and greater than doesn't work. So now the answer for the first part will be f less than 17. For B, if you want to get a single point, f should be equals to 17 to get 0. If you have 0 here, it will be single point, which is the center, negative a half and 4. And the last case, greater than 17. If it is greater than 17, it will be negative and no graph at all, because positive plus positive cannot be equals to negative. The sum of two squares cannot be negative at all. This is an old exam question, very similar to this exercise. It is really very, very old exam question, but you may have it. Why not? As you have, of course, an exercise in your textbook, you may have it like that. So please, I will leave it for you to practice and solve it. Also, you can see also I have added here an exercise about this idea. Also, you can find in the very old exam questions some questions about the degenerate conics. So this will be what? A hyperbola or no graph or a point or a parabola or an ellipse. Of course, it is not going to be a parabola. It is not going to be what? A hyperbola. Clearly, it could be what? An ellipse or no graph or a point. So you have only 3 options here. And in fact, it will be a point at the end. It will be the center. You can practice, and we can say now it is alhamdulillah done. Let me stop the recording and talk about the last class. Alhamdulillah.